Right, a rectangular piece of cardboard is 2 centimeters longer than it is wide. From each of its corners, a square piece, 2 centimeters on the side is cut out. And flaps are turned up for an open box that has a volume of 70 centimeters cubed. Calculate the dimensions of the cardboard. So, as always, we've got to make our little notes. Yeah, that's first little bit of your notes. Draw. So what am I drawing? I'm going to draw a rectangle, exactly. So a rectangular piece of cardboard is 2 centimeters long than it is wide. X plus 2 is the length. And how wide is it? X. Right, x plus 2 is the length and it's x wide. Right, next little thing, what do I do? Sorry? Squares, go man, yeah. We're going to draw a square, so we're going to cut squares. How are we going to do that? Much easier than that. From each of its corners, a square piece, 2 centimeters is taken. So literally from each corner, cut out a square. What's the length from here to here? 2 in here. Here to here. 2, 2, 2, 2, 2, 2. Right. What does it tell us then? What does it do? Before you do that, what does it tell us? We've only done the first 2 bits of the lines. We haven't attacked the last bit of it yet. Flaps are turned up to create an open box with a volume of 70 centimeters cubed. Right. What do we need to do for this? Need to flip up the sides. Obviously, we're not going to touch that. That'll be too messy, so we're just going to go away and draw another one. Off we go and draw another rectangle. Draw a box. So, here's it flattened out, and here's it up on top. So now I have all my sketches done. How am I going to go about getting the dimensions for the cardboard? Volume, good man. What's my volume? 70 centimeters cubed. Any idea what the formula for the volume of a box is? Before you even go putting in x's and x plus 2's. What's the? Length by width by height, good man. Length by width by height, and I know that's 70 centimeters cubed. Right. Any idea how I'm going to get the length, the width, or the height? I have them up here. Right. What's my length, so? Oh. which is x minus 2, exactly. My length is x minus 2. X plus 2 and take away 2 from either side is x plus 2 minus 4. Right, that is length. My width, x minus 4, so length is x minus 2. Width is equal to x minus 4, and height, 2. Why 2? Because we're flipping up the sides. So it's x minus 2 by the width, is x minus 4. X minus 2 by x minus 4 by 2, which is equal to 70. Jack's please just will you give me an answer now? Again, please. Oh, so x bracket by bracket, x by x, x squared, x by minus 4 minus 4x, minus 2 by x minus 2x, minus 2 by minus 4 is plus 8. All times 2, which is x squared minus 6x plus 8. All times 2 is 70. 2x squared minus 6x minus 12x plus 16 is equal to 70. 2x squared minus 12x, 16 minus 70, minus 54 is equal to 0. What do we do? Messed up the multiplication. What do I do here? Bracket, bracket, quadratic or guide number. Quadratic or minus b. What can I do to make it easier? Divide across by 2. That's x squared minus 6x minus 27 is equal to 0. What am I going to go with? 9 and 3. What way? Minus 9 plus 3. X equal to minus 3. X equal to 9. And we reject that. We have to be able to fly through those quadratics. That's why I put them up there for the homework. Because then you have to be able to boom, straight through them. I put 9 of them in the homework. You can't let something like that slide down. Like especially one that's at hand, you should be able to spot that it's 9 and 3 straight away. Is that right? You won't have time in higher level maths. It to be boom, 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 boom. Is that okay? As I said, there's a few more of those in the homework again tonight. It's just practice with them. Practice, 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 practice. Because while these might not have individually come up on their own on the exam papers, all the questions are so wordy. If you can't figure out what the question is asking you, you can't start the question. So you're going to get a 0. It's all about half the battle with maths is figuring out what the hell is the question asking me to do. Is that fair enough? That's why these word algebra equations are so important. They mightn't come up on their own, but they'll be buried inside the middle of the question. You're like, what is the question asking me to do? If you can't figure it out, you can't start. If you can't start, you get 0 marks. Is that right? Right. Next little thing we're going to jump onto. Two seconds. Right, we finished up the last day with fractions. So, following. Substitution. Solve the equation 4x squared minus 12x plus 5, hence solve 4 times t over 2 minus 1t squared minus 12 times t over 2 minus 1 plus 5. Right. Anyone, any idea what I'm going to be doing here? Find an x, so what am I going to do on top? So, sorry? Solving for x, yeah, but how am I going to do that? Quadratic, so 2 ways of solving quadratic. Minus b n. Right, off you go, quick, fly through it. Minus b or bracket back, whichever you want to do. Make up your mind. The heading is quadratic substitution. What do you reckon, guys? What do you get for x? Sorry? 2.5 and 5, let's look at it. 4x squared minus 12x plus 5 minus b is our guide number, and you get 2.5 and 5. Is that alright? Right. Anyone know how we solve the second? Solving what? Not course. First thing we got to do is, does anyone spot anything? Well, I don't know what the most important word anyway. This is very, very important. Especially for exam papers. I don't know what that word, why that word is so important. Very, very important. It means you use your answer from the top. The minute you see hints, straight away you're using your answer you got the first bit of the question. Alright? Hints is a very, very, very important word, and that's what it means. So, looking at our two questions, do you spot any similarities between our top line and our bottom line? All of that. All the coefficients are the same. What is the only difference between the top line and the bottom line? X has been substituted with something else. This is why this is known as a quadratic substitution. They're after taking out the x's or the y's or the r's or something, and after substituting it in with something else. What is the direct value for x in the second bit? Exactly. Not t over 2 minus 1. Because instead of 4x squared, I said 4 times t over 2 minus 1. Instead of minus 12x, I said t over 2 minus 12 times t over 2 minus 1. It's not just t, it's t over 2 minus 1. So we know that t over 2 minus 1 is equal to x. And we know the value for x is 2.5 and 0.5, because we figured that out over here. So instead of t over 2 minus 1 being equal to x, t over 2 minus 1 is equal to, or t over 2 minus 1 is equal to 0.5, and it's solved from there, right? Off we go, we get the value for t. Jakey? Sorry? 7 and 3, is it? Sorry, my hearing is absolutely horrendous. Let's look at it. So, t is equal to, t over 2 minus 1 is equal to 2.5. Multiply across by what to get off bottom line? By 2. T over 2 is equal to 3.5. Multiply across by 2, as I said, t is equal to 7. T over 2 minus 1 is equal to 0.5 plus that. T over 2 is equal to 1.5 multiplied by 2. T is equal to 3. So, the start of this is the exact same, i.e. all you're doing is the quadratic. The only difference is you have to do a bit of substitution on the bottom. Right, one of these on your own from the very start. Have a go at this one. I'll be floating around. And do the bracket on it, minus b. Right. First bit of this is the catch. They're looking off for a second. Because we're a bit slow. You need to do this to learn how to do it quickly, right? I'll look it up. 3x squared plus 16x minus 12. I teach my lads in first, second, third year how to do this, and eventually fifth year. I teach them the bracket way. But if you get your head around this bit first, you never get around. Then you can, when you get kicked off that, you can jump straight into the bracket. Fair enough? This is known as guiding. Can't take any more than maximum 30 seconds to do these. Is that right? It's just at this level you can't take any more than 30 seconds to do it. So spending 2 minutes on it is far too long. And it's showing your head, it's right there. You'll never get it wrong if you do it like this. Guide number. Multiply your first number by your last number. 3 times minus 12 is minus 36. Add to give us your middle number. Your middle number is 16. Factors of 36, which will multiply to give us minus 36 and add to give us 16. Give me the factors of 36. 12 and 3. 66. 9 and 4. These with 2 and 3, 4. Anyone else? What's missing? 2 and 2 and 8. Right. Which one straight away do you know it's going to be? What? 2 and 18. What way? Minus 2 plus 18. That's going to give us 16 multiplied 2, and what gives us? Minus 36. 3x squared plus 18x minus, as we give from 8 from in, minus 12 is equal to 0. What's common between 3x squared and 18x? 3x. What's that in the brackets? X plus 6 minus 2 times x plus 6. 3x minus 2 by x plus 6 is equal to 0. You have to go back and learn how to do it guiding no matter way. If you can't do the bracket quicker than 30 seconds. So it's either one way, that's enough to get this done. If not, you're going to have to go back and do this. I had 3 examples in the notes. You shouldn't be doing this in 50 level. You should be able to get this in 30 seconds flat. And that's what it is. And literally, guys, for some reason, times tables, the students got it, and it's not means not enough in school. You have to learn times tables. Is that fair enough? A lot of people know, like, if you don't know what the factors of 36 are, that's a problem. That has to be clear. Is that okay? There's no point knowing how to do the substitution if you don't learn times tables. Right, moving on from there. X is equal to 2 over 3. And x is equal to minus 6, right? Finish off the question. So as I said, if you can't do this in 30 seconds, go back and do the guide number minute because you're going to do it straight away. Anything more than 30 seconds on this is too slow. Looking fairly right. So it's the easy bit. The junior cert bit that's catching us. The leaving cert bit we're seeing to be fairly grand. So as I said, we solved this, and we got x is equal to, what did I say? 2 over 3 and minus 6, is it? X equal to 2 over 3. X equal to minus 6. So x is equal to y minus 7 over y, and x is equal to y minus 7 over y. Is that alright? What's x? 2 over 3 or 1.5, sorry, not 1.5, leave it as 2 over 3, is equal to y minus 7 over y. X over here is minus 6 is equal to y minus 7 over y. Right, what am I going to do? Multiply across by. And this one over here? Y and, not just y, 3, must be 3y. 3y, 3y. Alright, must be 3y. You have y in the bottom line here and y and 3 in the bottom line over here. 3 cancels with 3. You're left with y times 2 is 2y. Y multiplied by 3y? 3y squared minus 7 over y multiplied by 3y. Y is cancelled, minus 7 by 3. Minus 21. 3y squared minus 2y minus 21 is equal to 0. What am I going to do? How? Bracket, bracket, or guide number. Three y and y. What am I thinking? Minus 7 here and then 3. What way? Minus 7 plus 3, y is 3y squared, plus 9y minus 7y minus 21. It literally has to be that quick. That's as long as you can spend on that. Is that fair enough? Can't be spent any longer. 3y is equal to 7, y is equal to 7 over 3, y is equal to minus 3. Over here, the same thing. You're getting 4 answers, yeah. Over here, I'm multiplying across by just y, they knock, and it's going to be minus 6y is equal to y squared minus 7. Y squared plus 6y minus 7 is equal to 0, bracket, bracket. Y and y, minus 1 plus 7. Y equals 1. Y is equal to minus 7. You get 6 answers in total. 2 of these and 4 of these. Is that right? Don't do another one of those before you jump on. Right, I'll go at this one. Right, first things first, factorize the first bit. bracket bracket, x and x, minus 6 plus 4, x equal to minus 4, x equal to plus 6. So, x plus 4 over x is equal to x. Therefore, x plus 4 over x is equal to minus 4. Multiply across by x, x, x. X squared plus they cancel with each other, plus 4 is equal to minus 4x. X squared plus 4x plus 4 is equal to 0. Bracket bracket, x and x, plus 2 plus 2, x equals minus 2, x equals minus 2. Is that okay? Over here, x plus 4 over x is equal to x, x plus 4 over x is equal to 6. X squared plus 4 is equal to 6x. X squared minus 6x plus 4 is equal to 0. Didn't do anything wrong here now. X and x and doesn't work. Nope, doesn't work. Minus b at 2 seconds. Minus b is 6 plus the square root of minus 6 to be squared minus 4 times a, which is 1, times c, which is 4, all over 2 times 1. Yeah, you get, doesn't work like that when you factorize it, you get complex roots. You get 3 plus root 5 and 3 minus root 5. It doesn't work for you, it minus b. Is that alright? No need to work out your minus b either, as you can do the whole sum on your calculator. Once again, that's in the notes. Is that right? Fly through. You don't, like, do you know what I mean, like when you're in next door, they get you to work it out through the lines. It's in, like, for example, take the one on the board. A lot of schools make you do this as in A is 3, B is 16, and C is minus 12, yeah? Minus b plus minus the square root of b squared minus 4ac all over 2a, and they will tell you minus 16 plus minus the square root of 16 squared minus 4 times 3 and minus 12 all over 2 times 3, yeah? Then they tell you minus 16 plus minus square root of 16 squared over 16 squared. Is that better? 256 minus 4 times 3 minus 12 minus 12 plus 144 over 6, and then they get you work another line. Completely pointless, you get 0 marks. The only thing you need to do is put that there, straight into the calculator. From that. Is that right? Don't worry about that. It's too slow. At least or better, you only you should need to be writing it down. You should just literally what's A, what's B, and what's C in your copy, and put it straight into the form. Is that alright? You ever want to run out of time doing your leaves or maths, or keep them higher than maths, you're going to run out of time. Where you cut down time is big thing. So cutting down time, i.e., doing these as quick as possible, or you can't do it, firing that straight into the calculator when we're working on it. Is that right? That's just calculator work. Right, moving on, let's do those practice. Is that right? Right, next thing we're going to look at. Modulus. So, modulus and irrational equation. So this comes up every single year on the leaving cert and shown in some shape or form. So you see those two lines either side of 3. What they mean is the modulus of 3. So that means either x is equal to 3 or x equal to minus 3. It means plus or minus. Is that right? Modulus means plus or minus. So for example, solve the following equation for x. X minus 1 is equal to 4. The modulus of x minus 1 is equal to 4. Now, you can do this one of 2 ways. What's the one way you probably know to do it? You square both. Square both sides to get rid of the modulus. Why do you square both sides to get rid of the modulus? Because it makes it positive. Exactly. Because x minus 1 is plus or minus, if we square both sides, we go for a fact. It's positive, i.e. x minus 1 to be squared equals 4 to be squared, which is square the first, x squared twice the first by the second. Do you know the quick way to square things out? Square the first, twice the first by the second, and square the last. You can do it the old way, you can simply just say x minus 1 by x minus 1. As I said, I don't need to take this down, it's all in the notes. Plus minus 1 to be squared is equal to 4 to be squared. X squared minus 2x plus 1 is equal to 16. X squared minus 2x minus 15. You get your two values for x, which is minus 3 or 5. Which makes sense. I told you, what did I tell you at the beginning? What did I tell you at the beginning of this meant? Means plus or minus. So x minus 1, modulus of x minus 1 is equal to 4. That means x minus 1 is equal to plus 4, or x minus 1 is equal to minus 4. That means x is equal to 4 plus 1, x is equal to 5x is equal to minus 4 plus 1, x is equal to minus 3. There's your two answers. That's what you're actually doing when you're squaring it up. Is that right? A lot of people don't know that. That's what the modulus means. It means plus or minus the answer on the other side of the equals. So x minus modulus of x minus 1 is equal to 4. What you're actually saying is x minus 1 is equal to plus 4, or x minus 1 is equal to minus 4. That's where your answer of 5 minus 3 is. This is the way you're taught. It's important that you actually understand what you're doing. That's a big thing in the exam there, is actually understanding what you're doing. Is that right? So when it comes up as simple as this, you can just do that method if you want. But the easiest way to get it right the whole time is you square both sides. Right, let's do a few of these. Do for me. Modulus of 3x minus 1 is equal to 4. Modulus of 3x minus 1 is equal to 4. Right, so have a little look at it. So, I'll do it both ways to show it can be done. These handy ones can be done both ways. So that is three x minus 1 is equal to 4. The modulus of 3x minus 1 is equal to 4. So, easiest way to do it is square both sides one way. So, the quick way to square, and just so we're clear, square the first plus twice the first by the second plus square the last is literally the exact same thing as saying 3x minus 1 by 3x minus 1, right? That's just a quick way of doing it in your head, is that okay? Just in case you ever hear me doing it and going, what the hell is going on? That's what I'm doing. It's just a quicker way of doing that. Is equal to 14 squared, which is 16. 3x to be squared is 9x squared plus minus 6x plus 1 is equal to 16. 9x squared minus 6x minus 15 is equal to 0. Divide across by 3 to make life easier. 3x squared minus 2x minus 5 is equal to 0. Bracket, bracket, 3x and x, minus 5 plus 1. 3x equals 5, x is equal to 5 over 3. X is equal to minus 1. The quicker way to do that, the modulus of 3x minus 1 is equal to 4, is 3x minus 1 equals 4, 3x is equal to 4 plus 1, 3x is equal to 5, x is equal to 5 over 3, 3x minus 1 is equal to minus 4, 3x is equal to minus 4 plus 1, which is minus 3, x is equal to minus 1. Either way you get the same answer. Is that right? Important to notice that little thing on the right, especially on exam papers. It can actually save you a lot of time. Alright, we'll do one more of these ones before we move into the doubles. So have a go at the modulus of 2x plus 1 is equal to the modulus of x minus 1. Get me a value for x. 15 minutes left, please. Squares, rearranging one side. Right, I say we're just getting caught at the very end. So, squaring both sides. Is 2x plus 1 to be squaring both sides. Square the first is 4x to be squared. Twice the first by the second is 2 times 2x by 1 is 4x Square of the last is 1. Square of the first, x squared, twice the first by the second is minus 2x, square of the last, plus 1. 4x squared minus x squared is 3x squared, 4x plus 2x is 6x, 1 minus 1 is 0. I'll get down as far as here, it's said to be. Yeah. Quadratic, when we can't take out, when we don't have 3 numbers, take out highest common factor. Highest common factor, 3x squared and 6x. 3x. You're left with x plus 2 is equal to 0. Line down the middle. 3x is equal to 0. X is equal to 0. X equal minus 2. Is that right? Right, guys, so these get a small bit harder. So we look at the following. 3x plus 1 over x minus 1 is equal to 2. Right, looking up, so we have to square both sides to make sure that we're dealing with positive numbers, which is 3x plus 1 to the squared over x minus 1 to the squared is equal to 2 squared. Literally, multiply across then by x minus 1 to the squared. The reason we multiply across x minus 1 to the squared is get this off the bottom. I leave this example up when we're doing another one, so as I said, everything goes up and then you don't have to take this out. Everything goes up. They knock out. That's 3x plus 1 to the squared is equal to 4 times x minus 1 to the square. Square to the left, square to the right, then square the first, 3x squared, twice the first by the second, square the last. 4 times square the first, twice the first by the second, square the last. That is on your left hand side, 9x squared plus 6x plus 1. On your right hand side, 4 times that. Move everything to one side, you're left with 5x squared plus 14x minus 3. Factorize it and solve it. The only difference here is when you're squaring it in a fraction form, you need to get this off the bottom line straight. So multiply across by whatever is on the bottom line to be squared, they're going to knock, and it's going to come over to this side of the square. Is that right? We're going to try one of these. I'll leave that example up on the board. I'll go and follow it. X minus 2 over 3 is equal. 5 minutes left, please. We're looking at 5 and minus 1 of me. Good stuff. Right, so x minus 2 over 3 is equal to 1. Square both sides. That's x minus 2 to be squared over 3 to be squared is equal to 1 to be squared. Multiply across by 3 to be squared to get it off the bottom line. Square it first. X squared minus 4x plus 4 is equal to 9. We all happy with that? X squared minus 4x, 4 minus 9 is minus 5 is equal to 0. Bracket, bracket, x and x, minus 5 plus 1, x equals minus 1. And x equals positive 5. Good stuff. Right, another way this can come up. So this is very like when we're dealing with square roots. So the following. X plus the square root of x plus 7 plus the square root of x is equal to 7. Now, this is one of the more difficult questions. Once again, they're incredibly fond of this question. When we're dealing with square roots in this situation, we want to get rid of them. We want to get rid of them to make sure that we can solve it. When you're dealing with two square roots, so for example, this question would be very simple if it was just simply the square root of x plus this would be very easy to deal with. This is simply just x plus 5 is equal to 20, as in the square root of x plus 5 is equal to 20. The reason it's simple to deal with is if you just simply square both sides, that will be x plus 5 is equal to 20 times 20, which is 400. X is equal to 400 minus 5. X is equal to 395. However, this question becomes a lot more difficult when you have two square roots. So this is junior kind of stuff, grand. This is when it becomes the first thing you must do when you're dealing with two separate square roots in question is move them to opposite sides of your equation. Is that right? So, like follow. The square root of x plus 7 plus square root of x becomes the square root of x plus 7 is equal to 7 minus the square root of x. Right? Now you can square both sides to get rid of your square root. The most common mistake people make here is they tell me this is 49 minus x. It is not. And never will be. I told you to square out x plus 2. What would you do? Square the first, twice the first by the second. Square the last. That is what you're squaring here. You are squaring the entire thing. You're not squaring 7 separately and squaring minus the root of x separately. You're squaring the entire thing. So what we must do is, we say, on the left it cancels, but this becomes 7 minus root x by 7 minus root x, and you must properly square it. Is that okay? Very, very common mistake, and they love throwing that question up because you keep making that mistake. Step the first thing you must do. Two square roots in the question. One is on the left, one must be on the right. Get rid of the square root, square both sides. Do not square individually. It is one whole statement. You must square it like normally or like you would a bracket. That's x plus 7 by 7 times 7, which is 49. 7 by minus x, square root of x is minus 7 root x. Minus root x by 7 is minus 7 root x. Minus root x by minus root x is x. I don't know if you tell me what minus root x by minus root x is x. Root x squared and the square roots cancel. Is that right? And then minus by minus we do plus. That's x plus 7, x minus x plus 7 minus 49 is equal to minus 7 root x and minus 7 root x. Because they're the same, you can add, you get minus 14. X is you're left with minus 42 is equal to minus 14 root x. What do I do? to square both sides again, exactly. 1,764 is equal to 196x. What though is different between this and what I had up here? Why didn't I have to say it? Why didn't I have to break that out? Why is this different to what I had to do up here? It's a single term, very important. Minus 14 root x is not the same thing as saying minus 14 or even 14 minus root x. That is two terms. This is one term. Very important. Is that okay? Divide across by what? 196, exactly. Divide across by the number from x, 196 to get that its own. X is equal to 9. That's came up 2 in the last 4 years. They love that question, and the years that didn't come up, they threw the Modulus question.
Are you able to predict what comes up?
No, would you compare? You can, paper 1, you will have a rough idea of about 65-70%. Paper 2, same thing. Because then they like certain questions. But there's probably like 30 to 40% of paper you just want to know what's going on here. It's going to be a lot easier to think of it, it's just the way they ask the questions. It isn't the worst one thing in the world trying to figure it out.
Tricks to understand the questions.
What?
Or like the main keywords in the question.
It all depends on the topic. You'll understand more, like we won't do too many exam paper questions this year, maybe next 6 year. Then when I'm doing grind 6 year, I started very beginning of the year, and it's like breaking up a topic, it's half the teaching the content and the other half is literally exam papers. The more exam papers you do for leaves like that, that's literally the only thing you should do in practice for leaves. Exam papers. Because it's not how to do the question. Like if I told you this question again and again, that's grand. But they sat that question inside the middle of something, we have to read it, understand it, and then try to figure out what to do. That's the thing. That's why I said earlier on, trying to understand what the question is asking you to do is the big thing in maths. But like if I'd be here with the exam paper on the board and you're kind of going, what's going on? Like for example, I'll give an example here so we go. Very first question, last year's paper, paper 1, very first thing they saw, and it freaked the shit out. Anyone, any idea what you're supposed to do there? Yeah. That's undetermined coefficient. That's what you did for homework. That's it. This came up last year. And they just didn't have a clue. They looked at it. Because it didn't ask you, didn't have a heading undetermined coefficient. You had to have to spot that word there. If you didn't spot the word coefficient here, you didn't know that was undetermined coefficient. You see what I mean? It was just a question like that. Literally, like the commodity exam was like, the first question and the two was boom, important word. Like when you do exam papers, you have a highlight for this whole important word. There's always an important word in the question. And that's boom, that's undetermined coefficient. He's asking